All right, 10. So let's look at the plane problem. So plane takes 4 hours to fly 2,200 kilometers from Saskatoon to Toronto with a tailwind, and takes 5 hours on the way back with a headwind. And so we need to determine the speed of the plane in still air and the speed of the wind. And we need to assume that the tailwind and the headwind have the same speed. So we'll start as usual with the variables, and so our variables are coming from our question. So we need to figure out the speed of the plane in the still air and the speed of the wind. So we'll let x represent the speed of the plane in the still air and then we'll let y, we'll let y represent the speed of the wind. Okay, so now we've defined our variables. We need to figure out our equations. So before we do that, I just want to kind of go over a little bit about what it means when we're talking about tailwinds and headwinds. Okay, so we can think of the fact that our plane is flying at a certain speed. Okay, and if there's a tailwind, that means that the wind is behind you and it's pushing the plane. So that means that the speed, right, whenever there's a tailwind, the actual speed of the plane or the actual speed is going to increase, because the plane will be flying at a certain speed and the tailwind will be adding to that speed. Okay, so the tailwind adds to the original speed, or the speed of the plane. So it's ultimately going to fly faster because it's being pushed. If you think of when you're walking on a windy day and there's a wind behind you, the wind will actually push you a little bit so that you're traveling at a faster rate. So it's your speed plus the wind speed. And then if we think of a headwind, well, a headwind is coming at you, and so what's going to happen is we have the speed of the plane, but then the headwind is coming at it, so it is actually going to slow down the speed of the plane, or reduce the speed of the plane. So a headwind reduces the speed of the plane. Okay, so if we think about our equations then, okay, well, if we take a look back here, we don't actually have anything in terms of speed, but what we do know is it takes 4 hours to fly 2,200 kilometers, so we have time and distance, and we know that it takes 5 hours to fly 2,200 kilometers on the way back, so we have time and distance. So I just want to draw your attention, or maybe remind you of a formula that you have used in science and probably already in math, that speed is equal to distance divided by time. So if you know the distance and you know the time, then you can determine the speed. Okay, so as we said earlier, that if we have the speed of the plane, right, and then that's going to increase, so we're going to add to it the speed of the tailwind, okay, and that's going to give us the speed of the journey, which is distance over time. So in this case, we know the distance is 2,200 kilometers, and we know it takes 4 hours. And then our second equation then is going to be our speed of our plane, and because it's a headwind, it's going to reduce the speed, so we're going to subtract the speed of the wind, and in this case it's still flying those same 2,200 kilometers, so it's still covering the same distance, but it's doing it over 5 hours, and this is going to be our second this is going to be our second equation. So we can simplify those, all right? So if we take 2200 and we divide it by 4, we get 550. So we'd have x plus y is equal to 550, right? And then we would have x minus y, so we take that 2200 and we divide it by 5, and we get 440. So x minus y is going to be that 440, and that's our second equation. So with the plane and the tailwind, it's flying at a speed of 550 kilometers an hour, and with the plane and the headwind, it's flying at 440 kilometers an hour. Anyway, 10s, hope that helps. At this point, you can go ahead and solve it on your own.